Okay, are you okay so far? Okay, let's talk about number 7. Okay, it is really obvious process, right? We talked about how we can find the general solution in example 5 and 6. Now it is initial value problem. Okay, process is same. Find the eigenvalue, then find eigenvector, then we're going to apply the initial value which is given. Then we can decide coefficient C1 and C2. That's it. Okay, let's do it. Here we go. Start from eigenvalue. Okay, again, it can be found by determinant a minus lambda I equals 0. Okay, so we can use this notation as well. Minus 2 minus lambda 1 negative 5 4 minus lambda equals 0. Then the determinant of this 2 by 2 matrix is minus lambda times 4 minus lambda and plus 5 equals 0. Distribution, negative 8, and negative 4 and plus 2, negative 2 lambda squared plus 5 equals 0. In order, lambda squared minus 2 lambda minus 3 equals 0. What an easy factoring, right? Lambda plus 1 and lambda minus 3 equals 0. Then I have like two different eigenvalues. Is that clear? Okay. Then with these two, we have to find eigenvector. Okay. So first of all, let's start from lambda 1, which is negative 1. Then what you're going to do is a minus 1 I v is equal to 0. Okay. Which is plus 1, right? Minus 1, 1, negative 5, and 5. Let's say v1 and v2 equal to 0 and 0. Then we can easily find negative v1 plus v2 equals 0. In other words, v2 is equal to v1. Then my first eigenvector is 1, 1. Am I doing right? Did I make a mistake? Oh, that's it, right? So what about the second one? When lambda is 3, then we will do the same thing. A minus 3 I equals 0, which is negative 3, which is negative 5, 1, negative 5, and 1. v1, v2 equal to 0 and 0. Then from this guy, we can easily find minus 5 v1 plus v2 is equal to 0. I can say v2 is 5 v1. Then my second eigenvector is 1, 5. Okay, then with these two, we can set up the solution matrix like that. C1 e to the minus t 1, 1 plus C2 e to the 3t 1, 5. Okay, so like for this case, let me combine as one matrix. Okay, it is equal to C1 e to the minus t, C1 e to the minus t, and C2 e to the 3t, and 5 C2 e to the 3t. And now, initial condition, what was it? They said x0 equal to 1, 3, right? Oh, I'm sorry, like it's plus, right? Okay, give me 1 second. It's vector 4, right? Give me 1 second. Let me try to make it a little bit smaller. I need a little bit more space. There we go. So when you plug in 0. Oops. Where is it? There we go. Plug in 0. E to the 0 equal to 1. It's the 3t also equal to 1 as well. Then we have like C1 plus C2 and C1 plus 5C2 must be equal to 1 and 3. Okay. We can solve this one by system, right? C1. Actually, if you want to use the like inverse matrix, you can do that. But I would love to do like this way because this is much simpler. Let me do the elimination. Subtract. It will be negative 4, C2 equal to negative 2. Then my C2 is 1/2, right? Then automatically C1 is 1/2 as well to make it 1, okay? Then finally, I can write my solution vector like this way. 1/2 minus t plus 1/2 e to the 3t 1/2 plus 5/2 e to the 3t. That's it.